To apply the normal curve to real-life situations, you need to understand how the normal curve works. Here's a picture that shows the normal curve, and if you notice, it gives the percents that are in each section. Let's look at an example from our book. Suppose 100 people counted the number of cars passing an intersection in an hour. Due to error, not all people get the same value. The mean of their counts is 75, and if you notice, that lands right here. The standard deviation is 1. In other words, 1 standard deviation below, those people counted 74. 1 standard deviation above, they counted 76. Use the sketch to find out how many people reported between 74 and 76 cars. So we're going to shade that portion of the graph, and we want to know what proportion that is. Well, if you notice, it's 34% plus 34%, or if you notice, it says right here, 68%. It says there were 100 people, so 68 times 100 is 68 people. Let's look at another example, one that doesn't have the graph scoped out for us. Here we go. Suppose we were talking about a 100-yard dash race. In this case, we draw the standard normal curve. The average is 15.2 seconds with a standard deviation of 0.9 seconds. The times are approximated by a normal curve. Find the percent of times that are more than 15.2. Okay, so we want all of the times that are more than 15.2. Well, in this case, what percent is it that's up here? 15.2 is right at 50%. So there's 50% this way and 50% this way. So we would say the correct answer is 50% would be more than 15.2 seconds. Let's look at another example. Here we've got a situation with a light bulb factory. A company installs 5,000 light bulbs with each an average lifespan of 500 hours, the standard deviation of 100, and a distribution approximated by a normal curve. So we're going to get the normal curve here. And when we do, it tells us that the middle value is 500 hours, and each standard deviation is worth 100 hours. So this would be 400 hours, 300 hours, 600 hours, 700 hours, and so on. Find the approximate number of light bulbs that can be expected to last at least 500 hours. So we want from 500 hours and more. Well, we just, on that last question, found out that that is 50% of the time. Since it's 50% times 5,000 light bulbs, we get 2,500 bulbs. Let's do one more of this type. Let's do this one right here. It says a standard normal curve. 500 is the middle. 100 is each standard deviation. We want the ones that are going to last more than 400 hours. So we're going to shade this portion of our curve. What percent would that be? Well, if we go back to our standard normal curve that's in our book, we find that this is 50%, and this from here to here is 34%. So 50 plus 34 is 80%. 84%, excuse me. 84% times 5,000 light bulbs is 4,200 bulbs. So that's why the answer is 4,200. So this is how you do standard normal curve and the different kinds of applications that go with it.